Alright, go ahead, Dee.
Hey Heather, this is the Physics Bros.
Hi Heather.
That's Amar Khan.
Love you.
I'm Peter Doan. Turn that around. There's Fong. And we are here to teach you about the physics of Fast and Furious 7.
Is it 7?
Yeah, 7. Okay, 감사합니다. Go BTS.
Doormat. Doormat.
This video goes out to you, Heather Lee Ludwig. I love
No, we
love you.
Hi Heather and friends. We are the Physics Bros and we're here to teach you about the physics of Fast and Furious. Now let's take a look at this scene to determine whether it's plausible or not.
Kiss me.
John, cars don't fly! Cars don't fly!
I can fly, hey, if I just spread my wings. I can
Okay, now let's bring it to Peter to talk about some calculations to see if this scene is plausible. Hello, my name is William.
She bangs, oh baby, when she moves, I go crazy.
And today we're doing the physics calculation. Okay, so based on that Fast and Furious scene, the car dropped, or the car traveled between two buildings one block, which is 100 meters. So the change in x was 100 meters. And the car dropped about 2 stories, so the change in y is about 7 meters. And so based off that and the fact that they use a sports car, which goes 0 to 60 in about 3 seconds, we can figure out the calculation. So 60 miles per hour converted to meters per second is about, let me get my handy dandy calculator, and that's about 26.8224 meters per second. So change in velocity is 26.8224 meters per second, and change in time is 3 seconds. And so with that we can figure out the acceleration. I love you boy, I love you on y. Okay, so the acceleration, change in v over change in t, which equals, when plugging in these two numbers, 8.9408 meters per second squared. And so using that, we can figure out the max velocity it has when it jumps out the window. So based on that clip we just saw, the car took about 12 seconds going from 0 to jumping out the window. And so we can figure out how fast it was accelerating for. So it was accelerating 8.9408 meters per second squared for 12 seconds. So we can figure out the max velocity by doing 8.9408 times 12, which equals, one sec. Had to get a teriyaki chicken. And so that's about 107.2896 meters per second. And to do that, that's the max velocity. It has, so let's jump out the window. And so now we're going to try to figure out the plausible velocity needed to actually jump out the window before comparing the two and seeing if this was a plausible speed to jump out that window and survive the jump. And so to figure that out, we're using Kmax formula, which utilizes our change in y and force of gravity. So we're going to use change in y equals BOY times t plus 1 half at squared. So there's no initial velocity. Change in y is 7 meters, and that equals 1 half. Acceleration due to gravity is 9.8 meters per second squared, and we're solving for time. So doing those calculations real quick, to figure out that the time is 1.195 seconds. So using that, we can plug that into the velocity formula using our change in x that we already have to figure out the velocity needed to make that jump. So we'll do change in x over change in t, which is 100 over 1.195 meters seconds, and that equals 83.68 meters per second. So it does show that the velocity of the car in the movie is greater than the plausible speed needed to make the jump. So therefore, the physics seen in Fast and Furious is correct. And thank you for doing physics with William Hung. I love you, Heather. Lila.
She bangs, and wasted by the way she moves, no one ever looks so fine. She reminds.
In conclusion, we can see that the scene is plausible, which we didn't expect, but the numbers do make sense. The maximum velocity that the car can reach with its acceleration is 107 meters per second. But the velocity needed to make the jump as shown in the movie is only 83 meters per second. So because the maximum velocity possible is higher than the velocity you need to make the jump, we can conclude that the scene is indeed possible.
This guy is my baby. Hey, can you guys do something on there?
I'll be happy to.
Oh my god.
Can I get a dead smart?
I'm gonna freaking kill you!
Hey, I'm sorry you had to see that. So, I'm sorry.
My abdomen! My clavicle! Perfect. Alright, we don't... Alright, we're rolling, man. You gonna say something?